all about what database Uber is using, and what is the like all those features Uber is building to serve all those customers. Huh? So for that, I guess I need to share my screen. In just 30 minutes, we'll discuss the overall architecture of Uber system design, like somewhat like Uber, Ola, and all those cab services are using that kind of system design, that kind of architecture, and somewhat the DB as well. So let me share my screen as well, and just gives your thumbs up if my screen is visible to everyone or not. Just share. Hmm. Okay. Just wanted to know my screen is visible to everyone. A quick thumbs up. Okay, I think my screen is visible to everyone. So we'll just start like in this half an hour and 40 minute session. We'll discuss the some MVP kind of requirement, and then we'll move forward to our basic architecture and all those databases which Ola and Uber kind of services uses to scale their services. Huh? So the primary thing we can discuss here, we just select. Okay, fine. So we'll discuss two kind of things. The primary thing is functional requirement, and then the secondary is non-functional requirement. So what all those functional requirements? Let me just. Okay. So what all those functional requirement we can think. Gosh, just let me just increase this. Yeah, choose this. So what all those functional requirements? The primary thing is in the MVP, a user can see the caps. Huh? So I can write down the C caps. Okay. The next thing is if user like if you install the Uber app, you open you open your app and you can see all those cabs into your map. The another thing is a user can book a cab. And also there is another feature which can be a location tracking as well. So I can track where my driver is, okay, and what time is left, where it is coming, where it is going. Okay, this kind of functional requirement. And what all those non-functional requirement, whenever you are going for the system design interview, the very first thing you will do to note down all those functional requirement and all those non-functional requirement as well. Okay, let me just write down non-functional requirement as well. Okay, so the first one is whatever you are building in the MVP. So I'm thinking in that direction. Like whenever you are going for the interview, you'll be building application like Uber, which should be a global presence. So I can say it should be a global presence. So what does it mean globally? What does it mean globally present? So whenever like people using this app, there should be a like the data center should be a different geographical location, so that everyone like get a better response on the app. Huh? If someone is in the US, it should not happen like there should their request comes to the India server, and the latency should be very high at that point, that kind of point. Yeah? Then another non-functional requirement can be the latency should be low latency. The another thing is it should be highly available. What does it mean is highly available? That mean it might be possible you are in some remote geography or kind of the geography where you are struggling with the finding some commute. So at that point of time, these kind of services, this kind of applications play a major role. So your application should be the highly available. Customer should not face that kind of issue while trying to open their app and finding that kind of information like the 500 error or 400 error. Like application is not available at that kind of time. Okay, so the system or application should be highly available. The next thing is it should be a highly consistent. Just a minute. It should be a highly, what is happening, just a minute. Okay, it should be a highly consistent. So some of you can think about like this direction. This should be highly available and highly consistent. It is a contradicting a basic principle of cap theorem, where the we used to learn that thing ki if my system is distributed globally, in the distributed system, we can only achieve uh, the highly consistent and highly the C and A or C or A things. We can choose any of one of the things, but it should not like it should not like this. So there are a lot of features in the app. This should be a highly consistent, and there should be a lot of feature in the app which should be the highly available. So this is kind of mix and max thing. And the companies like Uber and Facebook, that kind of applications are really smart to how to take care of these things into their application. What things are really important to be consistent and what things are really important to be available. So that kind of mix max things are usually there. And because we know these are the distributed system, the partition tolerance will be always will be there, huh? The next thing we can discuss about in the non-functional requirement, which is a very important and everyone should discuss in the high level design interview, which is scale estimations, huh? So whatever you are going to build, whatever you are going to build, uh, what kind of scale you are expecting for these applications. So and trust me guys, we used to take really high kind of we used to do some kind of mathematics there and pick a number that can fairly comparable for the like the real applications. So or near about the real application. So for example, if I can tell the scale or discuss the scale for the Uber or Ola system, let me just write down the system with Uber and Ola kind of ride sharing app system. So we can think about there can be 100 million active users monthly. So that usually called as MAU in system design terms. And I can say we usually get 14 million rides, 14 million rides per day. 14 million rides. Just what is happening? The lag rides per day. Okay, that is the like I can say this is roughly a good estimation, good estimate, and that can relate on the real life system as well. Let me just take if someone have any doubt regarding uh, someone has any doubt regarding this functional and non-functional requirement. Is everyone on the same page? Hmm. Yeah. Hi. Hello, Rajneesh. So yeah, I guess everyone on the same page. Let's just move on. So we just discussed the design, the functional and the non-functional requirement of Uber and Ola ride sharing app. Now we let's move forward with the the basic architecture of this Uber and Ola design. Before move further, so we can discuss the basic problem that Uber is solving or they actually struggle or like to optimize these things, and day by day they are working on that kind of algorithm more to accurate these things and resolve the queries of the customer and the driver as well. That is basically what the problem statement is, I can say. Let me just minimize this the intensity of my pen, if I can do so. Stoke is this. Okay, this. ठीक है. Okay, fine. Now, so what is the problem? The basic problem, I can say. The problem is best driver, best driver align with the customer. How it happen in the system? So for an example, we can take an example of our city. Let's just suppose this is our city region, and how this ride sharing app usually do to solve this problem. They basically do the partition of your city into segments. How segmented divided into the city? So you can assume, there are a lot of rectangle. Your city is divided into a lot of rectangles. Okay, and each rectangle have some sort of segment id, some sort of segment id. For example, this has segment id 1, this has segment id 2, this has segment id 3, and so on, and so on. Okay, so for example, this is the segment id 1 and this is the segment id 2. Okay, and how a system works in terms of segment ids or the segments. You can assume in this system that might be possible in the city, the one cab is going from here to there, the crossing one segment to another segment. There are a lot of services, but the you can assume there is a one map service who is responsible to finding the dynamic location of this particular cab, which usually figure out in which segment the cab is. And if my customer location is this, and it is basically on the basis of lat long of the customer, it figure it out in at what segment the customer is. Okay, so primarily with the help of this segment id, they used to figure it out, like whenever we get the segment, at that time my algorithm try to fetch all those cabs into the segment. If there are a lot of cabs in this system, in this segment, my algorithm usually divide this segment. It might be basically this is the reason. You can assume there is a one reason, there is one reason. Let's suppose this is the reason ncr. Okay, in India, this is ncr, which is New Delhi, and this is highly crowded by the cabs. So you can assume there are a lot of cabs are there in this region. There's a lot of customers also are there. So you can assume this segment, I'm just basically uh, defining the zoom of this particular segment. I'm mentioning the zoom part of this segment. This segment can further divide into a lot of other segment as well, the chunks of other segments, so that my algorithm can work more accurately, and I can define or align the driver which is nearest to this particular customer. Okay, at the same time, you can assume if there is a one reason which is the remote area, or I can say there are not a lot of people are there, that are not much crowded. At the same time, same thing works are there as well. This can basically, oh, just sorry for that. Let me just Okay, so at the same point, it can do this thing. It can, okay, sorry, yeah. So it can basically merge the larger area. It can merge the larger area. It can merge the different segment IDs as well to serve in the better manner. So that if customer are there and try to figure it out in the segment ID, it might be customer is there. So it will basically fetch all those driver information in that particular segment IDs. Okay. And try to serve in the best possible manner. Okay. Okay. So this is some kind of, and this is very logical, and you can assume, for an example, let's just suppose these are the coordinates 0, comma 0, and this is the coordinate 0, comma 1. This coordinate is 1, comma 0, and this is 1, comma 1. So we can fairly identify it, 0, comma 4 and 0, comma 5 basically reside in that particular segments. Okay. Does this thing is clear to everyone? Is there any doubt till now I can take? Okay, I think there is no doubt till now. Let's just move forward to basic architecture. Okay. So I have just defined this the map service, which is basically for this particular thing. I can in the different session, or maybe we'll take another session where we will talk more about this map service, how map service works, which is basically dividing the city into the segment and tracking, taking care of all those computation. It can compute as well whatever the different distance between the driver, the nearest cab, and the customer location. And by finding these the location of the drivers and the distance between the drivers, it can basically automatically assign the best suited driver to the customer according to the rating as well. And further we will discuss what all those factors really matters to assign the driver to the particular customer. Okay. Now quickly just move on to the services level architecture, where we can define that kind of DB and all those things. What kind of DB Uber or Ola is using to storing the particular information. Okay, so we can define this particular. Okay, so let's just suppose this is the app. I can say this is a customer app, or the user app. Okay, and there will be a load balancer. There will be a load balancer, which is LB. Okay, load balancer, basically there is a customer app, and load balancer is responsible to all those requests whatever we are getting from the customer should be somewhat equally distributed on the particular different services. So we basically run our in the high level system we usually call as the servers. Okay, so there are different servers running. There are different applications running, and my load balancer is responsible to segregate our traffic in particular pods, like the different servers. Huh? Now I can assume there is a one service, user service. There will be a different kind of services as well, but let's just suppose there is a user service. And now you can assume this is not the particular one service. There is a replica of, or maybe you can say there is another pools, the different pools of the user service running on. The load balancer is responsible to sending this particular request to what kind of particular user service server. Okay, for the sake of simplicity, I just mentioned the one user service. You can assume there is a one different kind of copy as well the server are running. Okay, my load balancer send the request to the user service, and user service is actually connected to my DB. There is a user DB, the user DB. Okay, and this is the MySQL. What all those information is there? So the user DB is basically responsible to save all those user or the customer information. So what is my name, my email ID, and my basic details, what all those I at the time of registration, and the further other things as well, the number, email ID, the user DB used to store this. And same time there is a Redis as well. We use the Redis as well. So you can assume what all those system it is not happening, because this is a very huge app. There is a very large scale app. We cannot survive again and again query to my DB to serve my all those requests from the there. So primarily I'll go to the Redis and try to fetch all those information, whatever maybe I go to my user profile and try to fetch all those infos. And if I'm active user, my information will fetch from the Redis server as well. So basically we used to cache this information to Redis. Okay. And you can assume there is a lot of other things as well. Maybe the user went to their profile and try to fetch the information regarding maybe trips. Okay. So user service is responsible. This kind of API exposed by the user service. There are some couple of admin APIs where the user try to save the information about the user, the customer, and also will get this that kind of get APIs, which is basically exposed to the customer, used to like show all those information regarding the user. And apart from this, maybe user came and try to check. Maybe you can go on the app and try to click on the user profile. There are a lot of things which might be user service responsible to serve all those things. There can be a trips information where user service basically call the another API, another service, not the API, another service API, which can be a black box right now. That can be a trip service, and that is a trip service which is responsible to expose the internal API and give the information to the user service. These are the tips this customer have done in the past, or this is the trip which the customer will do in the near future. Okay, that can be a scheduled trip, and the user service will basically go and return back to the customer. Okay, so this is kind of the user service flow, user profile flow. The another thing, whenever you as a customer, when you open the app, there is a one flow is this. The another thing is which is our basic functional requirement, like see the cabs or book the cab. Okay, so for that, the basic MVP feature for this app, for that, what we'll do, we'll maintain the WebSocket connections. Okay. Just a minute. So we'll maintain the WebSocket connection. If you know about the WebSocket, if you don't know about the WebSocket connection, no worry. Maybe in this another session you can go and check about it, because we don't have that kind of time. We can learn this concept, but you can assume the WebSocket connection usually do in that kind of services where we cannot a lot of communication happen in the services, client and the server. So we cannot basically entertain, or basically it is not efficient to make a connection again and again to serve the information. So you can assume the WhatsApp is also maintain the WebSocket connection with the server, so that the latency should be low, and we don't need to do again and again the connection, because the information is really like they are really connected, and we need to pass information in really less number, like maybe the 5 second on the 6 second or the 10 second. So that kind of thing, in that kind of system we used to use the WebSocket connection. Okay, so what does it mean? Like we maintain the WebSocket connection with the cab request service, the cab request service. Okay, just a minute. The cab request service, and the cab request service behind the scene, the cab request service called the cab finder. The cab finder job is to find the best suited cab for the same the customer, and return back all those information to cab request service. And cab request service basically gives this information to the user app, like this is the driver which assigned to you for the particular cab, for the particular request. Okay, So this is the flow of user app. Let's just see the flow for the particular driver app as well. Same same like user service, the user app, that there is a one driver app as well. Okay, and the same as driver app, the user app, there will be a load balancer. Okay, and there will be one driver service. There will be a one driver service. Okay, so what is driver service? The same thing as the as user service. There will be a driver DB as well, which is MySQL, and we basically store all those driver related information to driver DB. And the same like the user service, there will be a Redis. We basically serve all those cache information from the Redis. Okay. Now, in terms of like the driver, so in the customer, we used to book a cab, and we use these kind of application to book for the cab. For the driver perspective, there will also a WebSocket connection. Okay, and there are a lot of bunch of the black box applications. There are a lot of applications which used to serve this information to the driver, and behind the scene, these basically services connect to the location service. The location service, and so what does it mean? So you can assume the driver service, driver app, whenever driver open the app, every time, in every 5 second or 10 second, through WebSocket, driver used to send their location to feed the system, so that my system can get the accurate information where my driver is, so that it can basically perform some sort of operations to find a cab. Okay, so this in some sort of 5 second or 10 second, my driver used to send this information, the live tracking of information to the location service, and my location service is connect to the map service, which I have just discussed in the earlier in the session, the map service, which basically to perform that kind of information, to map if we are getting any request from the customer, so that I can align the particular driver to that particular customer. Okay, so this is some sort of driver and user applications, the customer and driver application. I'll basically note down or write down the broader level of high level of architecture from this to just to show you the flow, the exact flow, what happened behind the system, and how these system are storing this information, what kind of information is reside, what kind of databases, and how the messaging is also the event, how event flow this entire architecture into our system. Okay, so before moving forward, let's just take input. Okay, hello, yeah, I have from. Okay, I'll discuss this thing. Please make circuit with the function like straight lines. Okay, okay, fine. I'll do the same, because I have really less time. That is what is Vedant. You can assume the web socket connection is something like whenever you do the API into the system, my and maybe in basically in your company, maybe you are calling some sort of third party API. So at that time, at that time, you make a HTTP connection, you do the request, you get a response, and you close that connection. In WebSocket, the connection will not be closed. Okay, it should be performed like it's not like it will be never be closed. But yeah, there are some sort of conditions attached to it. But yeah, you can assume for the duration, for the sake of simplicity, for some sort of time, you used to make some connection between the server and the application, and we don't need to again and again connect to the server to make a connection on basically close the collection to save our time. Okay. So for the sake of simplicity, you can understand it, but for the broader way, you can understand it well in the like maybe go to watch, or maybe you can see the article as well. Understand, understood. Please make sure. Hello, yeah, I'm okay. So before going forward, let me just call out one important thing. So I am just explaining here some sort of this, because discussing the Uber system design and low level and high level design will usually take 3 hours a class, 3 hours or two to three classes to discuss some sort of design, or to explain all each and everything in a better manner. It will take 5 to 6 hours of close, and in this class I'm trying to give you a glimpse of that lectures in 30 to 35 minutes. Okay, so coding blocks is basically launching their this boot camp course in 8th of December. You guys can go and see this particular course, where you can assume like we are covering each and everything from the scratch. So for the sake of simplicity, I can explain. So there are multiple module. In the very first module, you will learn the concept of competitive programming. So we'll basically grill you on the DSLGO part, which is basically the entry interview for every good product based companies. This is the module one. In the module two, we will basically teach you some sort of OS, DB, and networking concept. Okay, which maybe you forget in whatever you have learned in the BTech, but these are the important concept which basically sometimes which usually asked by the companies. Maybe there is some networking domain company which basically used to ask some generic journal things about the networking. Maybe some sort of OS based companies which basically used to ask some OS concepts. For an example, VMware used to ask some kind of OS concept as well. Okay, the third module the third module is low level design and the high level design. In the low level design, in the industry, you can assume you can see low level design in the machine coding round. The another name is machine coding round. Machine coding round is very famous in the top product based companies. The If you are going for the interview, more than 2 years of experience, you will basically you will see this round for sure. In any, you name the company, I'll tell you what kind of low level design they used to take in the MakeMyTrip as well. So right, my name is Archit. Maybe I forgot about to tell intro myself. uh, my name is Archit. I'm working in MakeMyTrip as a lead. So here as well, more than 2 years of experience or 3 years of experience, we used to ask the low level design. This can be a primary first round, or this can be a second round. But yeah, so this is the common round across the industry. Um, some people call as a machine coding round, some as a low level design round, where you used to define these services, or basically make this driver service and the cab finder or the user service in detail. What all those entities are there, what all those relationship between these entities. And the high level design is something what we are discussing right now. We used to discuss the non-functional requirement, the functional requirement, or to discuss the architecture of this and the DB designing as well. So that kind of thing is discussed in the high level design. And the module 4, we basically included the project as well. Okay, so where there will be a hands-on experience. So we have taken a couple of projects from the across the industry. So what all those projects are really famous: the user service, which is the common in every company, the workflow management. So we'll do any of the project from the scratch, and you will get to learn more about the industry work, how industry work, how to do code in this kind of repo in the real life company, and how we publish this code to or basically deploy this code to AWS, and what is Kubernetes, what is Docker image, end-to-end knowledge of AWS services as well, SNS, SQS, S3, Lambda, and we'll basically use the couple of services into our services as well, so that you will get more idea about this thing. And the module 5, which is the bonus, or you can say this is, you'll basically learn more about the AI tool. And there is a separate module where basically you will learn the front end language as well. So if you want to be a full stack developer, then basically you can extend your course and go for the front end learning as well. But yeah, for 4 to 5 module, you'll basically you can see yourself as from X to 10x engineers. Okay. Okay. So go and watch this course in the coding blocks. I'm a software engineer, Noida branch, the Tempura. Okay. Project is using which framework? Yeah, so project is using the Spring Boot. So this is the Spring Boot project. We basically, because you can see there are a lot of opportunities in specifically in Spring Boot and Java. So that's why we choose this as our primary language and into our program. So you'll basically get to learn more about, so you'll get to learn about the Java as well, and also we'll end to end we'll build this project in Spring Boot. And will basically whatever we have learned so far, the low level design, will basically implement it into our system, into this project. What we have learned the high level design in the previous module will basically implement here. Whatever kind of things like the caching strategies, the Redis, the different kind of DBs as well, we'll basically implement into our system. And whatever the Kafka and all those things we have learned, we'll basically uh, get more exposure, or basically the implementation phase of this will get learn more about this thing in the project. Okay, so you guys can go and watch this thing. And now let's move forward. I guess this session is uh, I was supposed to do this thing in 40-45 minutes, but yeah, no issue at all. Let's just move forward. uh, let's just make a proper architecture for the Uber and this kind of applications. So I'm just building and blog. So I think one guy has mentioned I need to basically build the blocks. So I'm trying to build it, no matter whatever the time will take. Okay. So let me just make the blocks first. Okay. So this I can say this is the user. Okay. This is the customer. This is the customer, which basically I can say the using the app. Okay. This is our cab request service. Cab request service. Okay. And there will be some web socket connection there in the customer in the cab request service. There will be a one cab finder as well, what we have discussed. There will be a one cab finder, the cab finder service. Okay. And the cab service and the cab finder service used to communicate each other. You can assume there is a one connection. Tick. Now, this is the customer side. Let's just assume there will be one driver side as well. So there will be some different drivers. Let's just take here. This is the driver D1. This is the driver D2 device. And this is the driver D3 device. Okay. So this is a D1 driver. This is the D1 driver. This is the D2 driver. And this is a D3 driver. Okay. And there will be a load balancer. There will be a one load balancer. You can say the load balancer. Okay. And here you can see there are couple of WebSocket handler. Okay, why I'm building this WebSocket handler? Let me just tell you. This is WebSocket handler. You can assume these are the same WebSocket handler. So, and there is a some connection between driver and the WebSocket handler. Now, in the real system, you can assume there are a lot of WebSocket handler because there is a lot of driver systems. Okay, but it will not be happen for the WebSocket handler will handle the particular one only driver. Yeah, there is a capacity of different WebSockets handler. So, but there will be a some sort of maybe in the real life system, in the real Uber system, there will be a couple of 500 or 1,000. I'm just assuming, but you can assume there is a lot of WebSocket handler which used to make connection between the driver and the application. Okay, so there will be a WebSocket handler, and also like above this, there will be a load balancer again in the system. Load balancer. Okay, and this WebSocket handler. Let me just write down this. This is WebSocket manager, which is very important, and you can basically assume the same thing happen in while you are doing you are using everyone using the WhatsApp here, huh? So you can assume there is a lot of WebSocket handler there as well, and there is a WebSocket manager which used to manage which driver is basically connected which WebSocket handler. Okay, why we are doing these things? Because the WebSocket manager is a brain for this. WebSocket manager has uh, these kind of information into the system. So whenever like maybe the D1 has requested something, then the WebSocket manager will do this kind of information. WebSocket manager will have this request came from the D1, so that we can whenever we in the system we'll get the response for the D1, we need to hand over for this WebSocket handler. So WebSocket handler used to tell the WebSocket manager ki all those information regarding the D1 will be sent like please send to me for the further communication. Okay, so this is the load balancer, and this information basically propagate to WebSocket manager, and WebSocket manager used to save this information. I'll say this is the in memory Redis. Okay, so as you can see the Redis is a cache, but we used to use heavily the Redis as a DB as well. You can see one kind of database as well. Okay, so in the Redis, what we used to store the mapping what driver map with the which host. Okay, so my D1 is basically mapped with the H1 host. That mean whatever the information we are processing for the D1, whatever the request, whatever the information we need to pass on the D1, we need to pass on this information to handler 1 H1. Okay, so this kind of mapping WebSocket will handle. Okay, now there is a cap finder, and okay, now there is a one other service as well, which is location service. Location service. Okay, and location service will communicate to map service. Please recall we have discussed this map service earlier when we were discussing about the segments, huh? Okay, so this is the location service. So in the WebSocket connection, whatever these information is stored to the WebSocket manager, but whenever the request came into the picture, so whatever the driver are there, all those driver will basically send their information regarding the location. They used to send this location again and again to the location service with the help of WebSocket, and this information basically persist into the system, which is basically the Cassandra. Why Cassandra? Right? Like give you some idea about this briefly. Oh, just a minute. What happened? This is irritating here. Okay, Cassandra. Okay, so why Cassandra? So Cassandra is very good for storing a large scale of data in less time, because again and again this is hitting or in across globally there is a lot of driver which are passing this information within 10 second or 5 second. This Cassandra is the best suited to scale in that manner, so that it is persisting this information into the system again and again. This kind of let long will basically use to make a journey. Okay, maybe we need to check or track from where to where this driver has gone. Okay, and this is the information we don't need to serve to the customer, or the even that can be used for the tracking purpose, for the job purpose. So we can basically give or like do the range query on the Cassandra, and we'll get these kind of information from the particular driver as well. Okay, so this kind of lat long, the information, the live tracking information will persist on the this Cassandra system. Okay, the another thing is Redis. Okay, what does it mean? The Redis is responsible. So I'll not take or explain the more about the map. The map is specifically, you can maybe in the further in the next discussion we can take example of Google Map, where we can basically deep dive these services. Okay, but you can assume this map service is responsible, and this Redis is basically try to store this kind of information like this S1 or the segment IDs, the close by the this close by the driver are D1, D2, and D3, and so on. Might be we usually store 10 drivers across this particular segment. Real life, okay, on the and the real time, we used to find out the nearby 10 drivers into the system, into this particular segment, and this again and again this can basically change in some sort of certain duration. Okay, so this kind of information or this kind of computation will be done by the map service. So map service and the location service is the you can say showstopper for this system design. Okay, now come to our cap finder. So there is one the cap service basically calls or connect to the WebSocket as well, and there can be some let's suppose I'll write down this trip service. Okay, there will be some trip service, which is, I can say, the trip service. Okay, let me just write down the whole diagram. I'll explain each and every term. This is a driver priority engine. Okay, and this is the another showstopper and the backbone of the system, which is Kafka. Sorry, spelling mistakes. The Kafka. Okay, and Kafka is connected to this. Oh, sorry, delete it. Kafka is connected to this. My cap finder will also pass on this information to the Kafka. And there is a tip service and trip service. My cap service is connected to the trip service. And my trip service is also connected. There are two different and there is some different. Okay, so this is a trip archival. I'll explain what does this service will do and what is the significance of this. And this is trip MySQLs, trips MySQL DB, and this is trip Cassandra DB. I'll explain the reason for both. Okay, so trip service is connected to this trip archival, trip Cassandra is connected to the trip archival, and this both of them is connected to this trip service. Okay, is there any connection I have? Left. Okay. Now, see this architecture, and I'll explain each and every time. Primarily, I'll discuss. So location service I have discussed. This information, whatever I'm trying to do, I'll persist on the Cassandra. The let long map service will be responsible for finding this driver from the segment ID. The cab request, the cab finder is the application which basically responsible to do this thing, is basically do the request to the location service, and to the trip service is responsible to whatever the trips. Okay, now what does it mean by the trip service? The trip service is responsible to define or do the trip service. There is one connection between the driver, this as well, this as well. ठीक? So trip server, so trip service is responsible, so whatever the trips going to be happen and whatever trip is running, these information basically will persist on the trip MySQL. Why in this trip MySQL? Okay, whatever the trip is going on, there are a lot of update will happen. There are a lot of information which we need to be consistent. So there, there will be a more make more sense. We need to persist this information in the trip MySQL because this is the not large data. Whatever the trip is happening right now and whatever the trip is going to happen nearby, maybe the next 24 hours, will persist this information to trip MySQL, and whatever the updates and the change will happen will do here. Okay, and what is the trip Cassandra? Whatever the trips the user has already performed or the driver has already performed, okay, that kind of mapping will store in the trip Cassandra. Okay, so the trip that was already performed and the history data will store in the trip Cassandra. Okay, so why we are doing this? Because this is the very huge data and will persist into the trip Cassandra to do a lot of computation. And who will do this? So whenever the trip has completed, my trip archival is activity or the job will perform these things and convert this kind of information and put this kind of information to trip Cassandra. So my trip MySQL will be no, like will not be having that kind of scale which is basically not assumable or maybe not expected. So we'll be having some sort of trips into my MySQL, and what kind of things going on live will be basically doing this information the trips. And whenever the trip service, so we'll expose some kind of APIs from the trip service. So we'll basically maybe my user service will ask what kind of services I have done in the past. So I'll go on the trip service, I'll ask the trip service will expose one API and will basically fetch this information from the board DB. So maybe whatever the trips will be happen in the upcoming future nearby, or the live will fetch this information from this trip. Whatever we have, like I have done this kind of rights in the past, will fetch this information that Cassandra, and both basically uploaded and serve this response to the customer. Okay, so this information served to the customer from the trip service. So there is a lot of different APIs which trip service is expose and will be responsible for the same. Okay, now come to the real request. Whenever the customer will do the request for the cab, this will go to the cab finder. Okay, now I'll discuss the negative scenario primarily. Okay, let's just suppose the cab finder, this request goes to the cab finder. Maybe I am in some kind of island, I did this request, and at that same time the response will come back, there is no cabs around this region, and I'll pass basically this information to my Kafka. So what kind of response and what kind of request is going to happen, this information, whatever I'm going to serve, whatever I'm getting the information request, I'll save this kind of information, this kinds of exception, this kind of error to the Kafka to basically train our model. I'll get more idea about this. So kind of analytic purpose, so majorly this used as analytic purpose and grow my business. How this basically, this is the key point to basically grow my business. So it will basically help to give me the matrices where I need to work more on. So I'll get more information about the area where I'm not getting that kind of request. So I'll get here, yeah, this is the area where I need to work more on, where, and we will get then idea. This is the demand and supply game. I'm getting more demands, but I'm not able to fulfill all those demands. So I have to basically push, or basically supply more cabs there. Okay, I need to increase the supply. So that kind of role the Kafka plays a lot. Okay, so from the service, cab finder will push this information, and there is a lot of other services as well. Will basically do that kind of information, or pass that kind of information from the location service as well to the Kafka. Okay, so we'll pass on this kind of event to the Kafka. Okay, now come to the real life positive scenario where the request came to the system, and this will go basically to the cab finder will go to the location service, and he'll basically go and ask the the nearby the drivers. Okay, it will basically go and fetch and ask the location service, give me the drivers which are nearby. Okay, now how map service usually do this, or take this request and do this request. Let's just suppose there is a this segment id is s1. Okay, and the customer is there, and let's just suppose my driver is there, or my driver is there, maybe my driver is there. Okay, this much of. And I told you in the earlier session that we used to fetch all those driver in the segment, but that might be possible there is one driver nearby this customer but in the different segment. Okay, so what we need to do, we used to do the query the segment as well as the nearby segment as well, the nearby segment as well. Okay, we used to do this kind of query to the system. And now by doing this thing, my map service and location service is responsible to give me 10 or 5 the best suited driver which can serve my request. This can be a S2, S3, S4. The segments you can assume will get top 10 drivers from this segment, which will be the best suited for the customer. It will basically return the cab finder. Now cab finder will ask from the driver priority engine to tell me whatever the best driver to serve the request. How it will do this? Okay, maybe I am very honest customer to the Uber, and I usually book my cab every day from the user. So I am the premier customer. Okay, I'm the premier customer. Okay, so if I am a premium customer, so the Uber should do a lot of things for me so that my customer experience should not be bad. So what Uber is doing, by by checking the different parameters of those customer, I'll align the best suited driver to this particular customer. Maybe I'm the very first time, or maybe I'm not that kind of loyal customer to the Uber. So basically I'll basically assign the decent, maybe there is a different parameters. Whatever the nearby customer is, whatever the nearby driver, just align this customer. Okay, so by doing this, so I'll basically align this driver. Let's just suppose from here it comes like D1 will be the responsible to take this drive. I'll do and ask the WebSocket key what will be the WebSocket handler for this scene. It will tell me the H1 will be the WebSocket handler. I'll go and ask, do this request to the driver D1. There's a lot of different things as well. Driver will accept this or not this, but I'm taking this happy request. Driver has accepted this. That I told driver this customer has booked this drive, and you are aligned for the driver, or you are aligned for this particular trip. Okay, and now come back to this, and again we'll go back, and cab request will go and tell the customer key this request is this, and this information, the driver is this, and the trip is this, and this is the route what the driver will follow, and you will basically go and reach your destination at that kind of time, in this much of amount of time. Okay, now in the same time, if user has the customer has this information, the same time cab finder will basically publish event as well, or maybe they basically call this trip service to basically persist this information to the trip MySQL server. This ride has just onboarded in the system, and now it is the ongoing ride, and persist in the system, and the live tracking will happen around the system. Okay, Okay, fine. So this kind of information I wanted to discuss. There is a lot of third party information as well. There is a lot of more I wanted to discuss, but due to some time constraint, I cannot discuss or express this thing uh, more. Okay, now let me just take input. First of all, okay, how data is nearby customer is collected since it is real time. Yeah, so the map service and the location service is really the responsible to doing this, all those computation on the real time. Okay, so because the customer is more or less standing on the same point. Okay, but the driver location changing. Okay, in 5 to 10 seconds, and my map service is responsible to do a lot of computation or and doing the pre-computation in very less amount of time to figure it out whatever the best cab will basically can serve this request at the real time. Okay, I'm working as a want to master will guide me over. Okay, so Devendra, there is no particular prerequisite. You should be consistent for the learning, and I'll say uh, take a good mentorship. Okay, and basically you can learn a lot of concept in the system design, and you will basically master on the system design interview as well. Okay, fine. In the Noida bench, okay, where can be a reverse socket? Okay, okay, fine. I guess I'm done from this particular session. I hope you guys really enjoy the session, and maybe for in the coming session, if I get more query from you guys, I'll take this kind of session again in upcoming weeks. But yeah, thank you so much for joining for this session, and hope you like we meet we guys can meet in another session. Huh? Thank you so much. Good night everyone. Okay, thank you.